How are you all doing tonight?
Great.
I'm glad you found your way in without getting blown out. So before I begin, I'd like to thank Miss Diane Hale, who connected me with this fair and the CATS program, and also Basha High, who graciously allowed a rival Hamilton student to be speaking here. I'm an 11th grade student at Hamilton High School. At the beginning of this school year, I founded a club, Students for a Sustainable School, or SSS for short. Since then, we have grown to over 60 members. Our mission is to create a more sustainable and efficient school through the efforts of like-minded students. We have taken charge of the recycling program for the school, which is over 3,600 kids, are working to reduce paper and plastic usage in the classrooms and cafeteria, reduce energy consumption and the carbon footprint of our school, and increase general awareness about sustainability and the necessity to act now. Recently, we have teamed up with Intel to start an electronic waste recycling initiative for our school. In the near future, we'll be starting a composting program. With our large and growing membership, we are able to work towards real change in the school and community. We provide a forum for students' voices to be heard and their actions to be implemented. Okay, believe me, I've been through many speeches at talks and events through which I endured until the final merciful end. Now it's your turn. I'm just going to try to make this as simple as possible and as interesting as possible, but it's a serious topic. Now that I've gotten through the icebreakers, let's talk about breaking ice. Polar ice caps are disappearing, Greenland's glaciers are going, and Antarctic sea ice is melting beneath the penguins' feet. Facts like these are what made me want to get involved in sustainability in the first place. But first, what is sustainability? Anybody have any ideas? Some of the CATS kids here? Exactly. He said something that can withhold something. So my definition of sustainability, it means that it can last. It is long-term and it can be sustained. It can go on indefinitely without hurting animals, humans, or the environment. When we talk about sustainability, we look for ways to make our life more environmentally friendly, but that's not all. Smarter practices lead to more dependable resource supplies, cleaner cities, and more wild space for animals. That means that we can have a stronger economy, healthier children, and a place to relax and enjoy nature. Today I'm going to talk about how I got into this movement and how I coordinate SSS to be as successful as possible in the hope to give you guys some ideas for projects of your own. Since I was just a little kid, I've always been interested in animals. I would read books about animals, then watch some TV shows about animals, and then read more books about animals. But nothing compared to seeing animals in the wild. After my first camping trip, I was hooked. Running between the trees and looking for anything that moved, and then running away as soon as something did move. I developed a great interest for all things natural and everything in the natural world. From then on, my answer to the question, what do you want to do over break, was always, camping! National parks were a common destination. School also taught me a lot about the environment. My AP Bio class in sophomore year showed me how everything in the ecosystems are all interrelated. Every animal and plant is so important. If one goes away, all the others are hurt as well. Through school, I learned how important protection and conservation are to continue a sustainable world. But I also consider problem solving as an important ability in projects and change groups. For example, when I was a little kid, I used to watch the news almost every day. This started maybe in like 2nd grade. So it's something that we should really encourage all of our students to do here, starting from the youngest all the way up to 8th grade. Listening to the news kept me up to date on problems in the world. If you start to watch news from an early age, you start to understand how change works and what you have to do to get it done. It's not hard to do, but it just requires some patience. In high school, I got involved in UN, which is a competitive club where students take roles in different countries to understand international problems and how different nations approach those solutions. I highly encourage you all to participate in this problem. I know at Bogle Junior High School they have a program for the junior high kids, but definitely when you get to high school, you should try Model UN. And then finally, I learned a lot from PBL. This fair here, the Catalyst Fair, is something that I've been attending since I was in 4th grade at Basha Elementary. It taught me different ways to approach problem solving and all the different types of problems that affect our world. So the first thing I'm going to do now is break down my idea for problem solving. This would work for almost any of your projects and is a good way to approach any problem. The first thing to do is to find the problem and background info. Don't rely just on one source. Then figure out what you want to do about it. This requires more research. Then you have to find out what is possible in your situation. So, for example, you need to figure out what your school can do to combat a problem without going past, or let's say, without going to the steps that the government would do. You have to take it down to your scale and find the best fit for your society. And finally, the most fun step is to put it all together, go out and do it. You will have to get help from your friends and from adult mentors in order for it to be successful. Some of the problems that we combat in SSS are plastic pollution and deforestation. Plastic pollution is actually a very big problem in the oceans, which is a bit unexpected. A lot of times, plastic will, on a day like this maybe, would fly out of a trash can, end up in the sewage system, and finally work its way to the ocean. Another pathway is just through the litter stream. So plastic pollution has become an increasing problem in the oceans, and a well-documented reason is the Pacific garbage patch. This patch of, it's just a patch of garbage. It's a huge collection of garbage, which is greater than the size of Texas. So just take a map, put Texas out in the middle of the ocean, and that's basically the state of our oceans in terms of trash. According to the research institution 5 Gyres, over 315 billion pounds of plastic exists in the ocean right now. Along with deforestation, we also combat food waste. Solving this problem is a big problem in America because America is one of the largest producers of food waste. When you throw away food the next time, don't just think about wasting the food, but think about all of the resources, costs, and time that were put into making that food. And then you will realize just how much of a waste throwing away food is. Today, I hope you all get to visit our SSS booths, our sustainability stations. We have different demonstrations on composting, tracking your trash, paper saving, and fracking. So the number one thing today is you need to think about where your trash goes. There is no throwing trash away. It has to go somewhere. All of us in our daily lives can help to make a difference. It's not always being part of a club or some huge organization. It's not always linking hands and protesting loudly, although those methods can help. Now, more than ever, we need to start thinking about our use and throw culture. Now, more than ever, sustainability needs to transform from just an idea into our very lifestyle. Thank you.
All right, thank you very much. That's impressive, isn't it? That's what someday your kids will be thinking about doing that. So give him another hand. All right, so there are lots of fun things planned and lots for you to hear and think about today. So head over to C Building, stay warm, and learn something new today. Thanks for coming.
All right, let's go.
But we see the word art. And if we take out art from Earth, then Earth is just end. Most people think of art as colors, drawings, sculptures, and music. But there is so much more to art that is all around us, easily accessible, yet special than what we think it to be. A simple example. Do a Google search for the word art. What do you get? I got 90% of the research results showing art as paintings, brushes, pencils, but that's not it. Art is actually everything expressive. Hello, I'm Amanda. And I'm Sachi, and we both have a strong passion for art. But when we ask, what kind of art? Art in fact comes to us in so many different ways, all around us. In nature, in animals, through their features and emotions, among plants, through their colors, smells, and curves, in natural landscapes, through their composition and yet timeless evolving beauty. In all things man-made, in building structures, through their various forms, shapes, and textures, in the seemingly ordinary things of daily life, through the shape and color of your iPhone, water bottle, haircut, pencils, cars, purses, the list is endless. Thank goodness for that. Now let us look at ourselves. All our expressions and emotions are art. We usually think of artists as singers, dancers, painters, or even manicures. But we believe that every human, every one of you is an artist. In the way you dress, the way your hairstyle looks, the way you write, look, speak. Every emotion you express is art. With art all around us and in everything, Knox Student Academy takes art seriously yet effortlessly. And by that, we mean art is completely entwined in all aspects of learning, of how we learn the 7 C's. Communicate, collaborate, cogitate, connect, code, create, and construct. And what we learn: languages, namaste, ni hao, social studies. 7 years ago, our fathers brought forth on this continent science and mathematics. E equals mc squared. Our teachers find art into our everyday work and spark up our lives. Let us tell about a few specific but unique projects from our class that art was totally mixed with the core concept. We built a mini golf course to learn geometry concepts. We launched a high altitude balloon, learning weather, aerospace, and navigation. And we tested and designed lunar rovers to learn about gravity, while being creative and using the materials we were given. But there's a problem. Art isn't funded enough. Ka-ching! And our school is a STEAM program. STEAM stands for science, technology, engineering, arts, and mathematics. Art should be funded because, after all, art is everything expressive. Art is very important to us, and we believe it should be to everybody. Without art, there's nothing expressive. We believe that our world should enjoy all kinds of art and never underestimate it. We hope you're influenced by this, and remember, everything is art, and you guys are an artist.
And does that for every other place as well? So it looks like there's 6 lanes.
I can't take much more. I mean,
How did you get put on?
I could wonder about it. I'm interested. It would be fine. But trying to stay together and not together is just too much.
You're right. Carl? All the things, you're right. So when red is on top, it's going to take a picture. When yellow's on top, it's going to take a picture. Blue's on top. So it looks like all the colors are together, all the primary colors. That's how we're trying to get brown. A strobe light is something that flashes and turns on and off. And I can control the rate of it. Yeah, that's what the dial is at. There's only 3 lights. What I can do, what is this called? So every time the strobe light flashes, our light is every time we see light, we take a picture. So when the yellow's on top, it's going to take 1 picture, and then it's going to keep going all the way around, and when it's in single position, it keeps out of the picture. It's how you can get it to stand still.
The strobe is cool,
And I can make it turn left or right. I can also get more than 3 blades, even though there's only 3 blades. So here we see 6 blades.
So are you changing the number of oscillations?
Yeah, I'm increasing the speed. So earlier there was only one flash. Now there's two flashes. So when the red is on the bottom, it takes a flash, and then when the red is on top, it takes another flash. And it does that for every other relay as well. So it kind of looks like there's 6. And you guys already saw it. That's how it looks.
I'll go sit down.
Yeah, so gathering
Actually, yeah, we'll just roll with this. No, I'm gonna wait 5, 10 more.
Don't touch the ice.
I know.
Oh, you cannot.
Gloves or no?
While they're sitting up, I was wondering if any of you guys have gone to any of the activities that we've had, or has people ever told you about them? Did anyone go to that? Raise your hand. Yeah. Yeah. Which one did you go to? The squid dissection? Yeah. Wow. That one's cool. Did you go to one?
You see the dissecting grasshoppers?
The dark room? No. I actually haven't done that one. What's that called?
Huge. Typical.
You said you went to one?
Locusts.
The squid dissection? Yeah, lots of people like to go to that one.
There's some upstairs.
Yeah.
They've got a really good science department here.
Actually, a pretty interesting one that I found was strawberry DNA. What they do is they mush up the strawberries, and they actually extract the DNA from the strawberries. So if you guys come next year, you should
awarded some
pretty fun.
pretty high
You guys ready?
awards.
Yes, I think so.
Have you ever thought about why you can't see in the dark, or why some colors are so bright? What, why, and how is color? When you think about it really hard, it seems really complicated, but on the surface, it's not that hard to understand. Color begins with the rods and cones in your retina that produce color, which process red, blue, and green. That is why we call those primary colors, because all the other colors are made up of them in our eyes. Some people that don't have as many rods are partially or fully colorblind. Our eyes need light to process color, so that is why we can't see in the dark. Light has different wavelengths. Microscopic waves, like when you drop a rock in water, or waves in the ocean, except only about as thick as a soap bubble membrane. Each color has a different wavelength, and the wavelengths bounce off your eyes to create color. Each color in a rainbow corresponds to a different wavelength of electromagnetic spectrum, starting from beginning to end, so red has the largest wavelength, and purple has the smallest. Even though our eyes primarily see green, red, and blue, mixing those colors can create other colors in the rainbow. Like if you mix blue and red, you'd get purple. Studies show that some colors affect your mood. Red is the most emotionally intense color. It's the color of love and simulates a faster heartbeat and breathing. Blue is peaceful, tranquil, and causes the body to produce calming chemicals, but it can also be cold and depressing. Green symbolizes nature. It is the easiest color on the eye and can improve vision. It is also calming, refreshing color, which is why hospitals use green to relax their patients. Purple is the color of royalty, wealth, luxury, and sophistication. And yellow is cheerful and sunny, but sometimes people lose their temper more often, and babies cry more. Without making it overcomplicated, color is just light.
Oh.